The class here examines applications in architecture for new materials. And these are materials that are less than 2 years old. They range in type. Some are biomaterials, so they biodegrade in the environment. And some are smart materials, so they change color, they change shape, or they emit light, or they change fluidity, or they change from soft to hard, depending on what they're stimulated by. And some are nanomaterials, so these are materials that are designed and engineered at the scale of individual atoms and molecules. I've asked the students to think about future applications for these materials because they're really so new that they're not being used in products or environments right now, but they show great potential for the future in terms of innovation. So the studio is focused on innovation, design innovation through a materials-driven approach. There are 2 exercises. The first exercise has students looking at some pretty conventional materials that are all around them today, metals, wood, polymers, ceramics, things that they're familiar with, but it asks them to reacquaint themselves with that set of materials by exploring their properties. And then for the second exercise, we look at some studies on advanced materials and start speculating about the properties that they have and their particular behaviors and what they might be useful for. The key in the project is for a student to identify an issue that the material helps them overcome. And I think one of the challenges for them is to really create an argument around why the material is vital to the work. The issue is, how do we take advantage of the things we make stuff out of? So the substances themselves. How these materials might be applicable in the future. We're always envisioning the future. Even with student projects here today, they're really making projections, drawings, and models on an envisioned future. So this is very much a part of that tradition where we're speculating about where things are going. And that speculation is grounded in history. One of the exciting things about being here is that this school in particular has a very clear focus on materiality and materials in architecture and a tradition of making through a certain set of materials. So this complements that by building on that strong foundation and actually bringing the students toward an examination of advanced materials and advanced manufacturing, which China is accelerating into right now. The trajectory is sort of very much, in terms of materials development and materials innovation in architecture, it follows a very particular course. So you have discovery, and then after materials discovery, you have often new materials arriving into architecture through other fields. So, they pass through product design or warfare or fashion or infrastructure and eventually into architecture. And you can go way back to cast iron technologies and look at that, for example, cast iron passing through products and warfare into bridges and infrastructure and eventually into architecture in the 19th century. It's the same with reinforced concrete starting in planters and boats and eventually winding up in architecture, or polymers, and now we have simply a new set of materials that have already passed through and being accelerated by product design and fashion and now are arriving in architecture over the past 15 years after being developed largely through those other disciplines. So, but all of that starts with discovery, and so the sciences are obviously involved in that respect.